In this video, I'd like to talk about using correlations, and correlations comes from chapter 56 of your book, if that's what you're using. Um, so, in the book that we use with our class, we talk about correlation being something that represents the strength of a relationship. In fact, a linear relationship between two different variables. Do they move up together? Do they move down together? So maybe age and income are two variables that move up together. Maybe some other variables go down, like if maybe there was the number of stupid mistakes you make per year. Maybe with age, as that goes up, the number of mistakes goes down. So there could still be a linear relationship, but instead of it being a positive relationship, it could be a negative relationship. So with that, why else do we care about correlations now that we understand what it is? Another reason we care about correlations as it relates to data analysis is that oftentimes you don't want two different variables that move together tightly to be used in analysis of certain types. So for example, if you were picking input variables for a regression that would predict some outcome, if you have two different variables that go up together or go down together, then as you run the procedure multiple times, sometimes you'll find that one variable comes out as significant and the other one is indicated as not significant, and then sometimes it'll switch, and so there's you know, it's confusing mathematically because both variables contain the exact same data, and so it's not that one's important and one isn't, it's that they are both essentially identical. And so for a lot of types of analysis, you want to have relatively unique variables used to predict some outcome. And so how would you know whether things are correlated or not? Well, let's go ahead and show how we might do that. I have here a list of stock returns that happen over a series of months, and we'll treat each of the different 5 stocks as different variables, and we'll see whether these things move up or move down together. Except rather than just making a pair of these and talking about just one pair's linear relationship, we'll create something called a correlation matrix, which allows us to compare all of them simultaneously. And a lot of research, scientific papers contain a correlation matrix because that helps someone reading the study understand what's going to happen next, whether or not people have included, for example, kind of redundant variables into some future analysis regression model. So in this case, I am going to go to the Data tab, Data Analysis. I guess I probably highlighted things prematurely. Click on Correlation. I'm going to grab the data that I have here, and there are labels in the first row. I will put the output over here. Okay, so right now I only see half of the data in my correlation matrix, and technically this is all we really need because what I'm about to do in a second is going to copy the data with mirror images onto the other half of this table. Our book shows us that we can do this, and so that's actually, so first I'll copy this, and then let's see, and then I'm going to do it a second time. I'm going to paste it, but this time I'm going to select this option that says, oops, okay, I did it in the wrong order. So okay, first I'm going to paste it using this option here that says transpose, so it flipped it across the diagonal. Then I'm going to copy it a second time and put it on top, and then when I paste, I'm going to select paste special, and I'm going to do this thing that says skip blanks, meaning from this top table let's not paste blanks onto this. And by doing this procedure, I now have a complete correlation matrix. And so now let's go ahead and interpret what we see in this correlation matrix. We see that the variable Microsoft is 100%. Now, by the way, these correlations go from -1 to +1, which really means negative 100% to positive 100%. Anything with a negative number means that there's well, let's talk about the positive ones. If it's anything from 0 to 100, that means it moves together, and the closer you get to 1 or 100%, the better the more they move together. Whereas if it's real low, down close to 0, then they hardly move together at all. And then if it's a negative number from negative 100, then it's a negative slope. So if you had like negative 100, that means like a +1 movement in one variable equates to a -1 movement in the other variable, more or less. All right, so I kind of jokingly say that Microsoft is 100% correlated with movements in Microsoft as you go from month to month. But in terms of Microsoft and GE, that it a lot, I don't know if we would say 44%, but 44% of the movement of an increase in Microsoft happens when there's a change in GE or vice versa, the way that they're written. We see that Intel and Microsoft are highly correlated. It's not a one-to-one relationship, but it's a pretty strong relationship. Now this one, 0.06, that's relatively close to 0, or it's like 6%. So those don't tend to move together very well. And then Microsoft and Cisco, they again pretty well move together. Not 100%, but 50%. Yeah, that's a pretty strong relationship in the strength of movement positively for one variable to the other. Now there's no negatives in this table, so as one goes up, nothing else goes down, and vice versa. Alright, so let's just take one of these numbers here, GE in Microsoft, it's 0.445043. Now look over here, this one says GE in Microsoft as well. So we get the same numbers on these diagonals if we look appropriately. And so that's just the nature of how this thing works. So although this is complete, it's not really necessary to have both sides of it. Something to point out then is what's highly correlated and what's not. I already talked about the fact that Microsoft and GE, Intel, and Cisco seem to be highly correlated, reasonably speaking. Let's think about some of the rationale behind that. Microsoft is a technology firm, so as its stock returns go up in a given month, chances are its software, in the past at least, is oftentimes sold in conjunction with a physical PC that has Intel chips in it. So as Microsoft or Intel's fortunes go, they go together. And same thing with Cisco. Cisco is a technology product. Now GM stands for General Motors, so it kind of makes sense intuitively that as a car company increases its car sales, it really doesn't seem to have any relationship to what's happening in the IT industry or to IT firm in particular like Microsoft. So as we go across here and we see GM and its relationship to Intel Corporation or Cisco, generally speaking, these IT companies are not highly related to movements in the stock returns for a car company. One last thing I might think about or talk about is, even though I've said that I'm looking for really high numbers because that suggests that there's this is a redundant variable then if I was going to use it in further analysis, it's also possible that we just want to be aware of how a particular variable moves in relationship to something else. So perhaps if I was a technology firm, I maybe don't need to be worrying about a regression. Maybe what I just need to know is how is some other firm in my industry doing, because that's a good predictor of how I'll be doing. So it can be used that way as well.